Hello everyone, this is Dr. Mahmoud and I'm here to talk about the Lean Six Sigma. And now it's time to talk about the analyze phase. In the previous phase, we talked about the measure phase where we use some data to measure the process. For example, we need to know if this is a scale data or if it's parametric, non-parametric data in order to make decisions. Once we collected the data, what we need to do, we have to analyze it. So this is why we're making this video, because we need to talk about the analyze phase. In the analyze phase, we have this input that came from the previous phase, the measurement phase. So as an input, we should have a well-defined process because we really dig deep into the details and we know exactly what the critical to quality is, what parameters to use, and these are really important. These are measurements. These based on number, based on fact, and then we have a well-defined process. Also, once we have a well-defined process, what we will have a baseline process capability. We know exactly what the process capability, what's the time to create one item, how much time do we need to serve one customer. We know some parameters such as CTQ, critical to quality. We know some other parameters such as cost of poor quality. So we start collecting these data from the previous phase. These will be input for this phase. And of course, we know some of the measurement system that we've done in the previous. So these are an input for the previous, an input for this phase, which is coming from the previous phase. Now, for the tool for the analyze, how we could analyze and find the issue, we have to use mainly 2 or 3 tools that we're going to focus on. There are other tools that you could find on the internet, but here we're going to focus on mainly 3 tools that we will be talking about, explain it, and provide some examples. The first one, Ishikawa diagram, or what's known as a fishbone diagram. The other one, the failure mode and effect analysis. This is another important chart that we're going to use. Hypothesis testing. I'm not going to focus that much in the hypothesis testing. We focused on this before in the measurement phase briefly, but we're not going to focus on this tool in this video. And the last tool that we're going to use, which is, I believe, the most important tool for the Lean Six Sigma, because it will give you an idea how to calculate the sigma level in a process. This is called the process capability study. So we need to do the process capability study. Once we used all these tools, we're going to have some output, such as important causes of defects. We will know exactly what the cause of these defects, why these defects happened, special and common cause variation, and we will have the DPMO, or the defect per million opportunities, and the sigma level. As I mentioned, these are the most important things. All right, let's go ahead and start with these slides. So the first tool that we're going to talk about is the fishbone diagram. The fishbone diagram, or what is called the Ishikawa diagram, or also it's called the cause and effect diagram. As you see, it looks like a fish diagram or a fishbone. On the right side, we put the problem. On the branches or the bone of the fish, we will have the people. We look into causes caused by the people. We look into the process itself, equipment, material, environment, and management. So once we look into that, you could look into the primary cause and you could look into the secondary cause as well. So what we need to do, we use this tool to identify the cause for non-conforming or defective products. The problem or effect is clearly identified on the right-hand side. So this is the problem, and the potential causes of the problem will be listed on the left-hand side, and you could categorize them by these categories. This is also known, as I mentioned, with the fishbone diagram or the cause and effect diagram. Another tool that something related to the cause and effect diagram, it's called the YY diagram. And in the YY diagram, you could ask why 5 times, and this is an organized way of thinking to reach to the root cause of the problem. So you say, for example, here, failure from supplier A that are 2x the industrial average. Why? Why is that? You say, okay, I need to know exactly why is that, and you say there's an oxidative damage in the transit. So another why? Because packaging is insufficient. Why? Because packaging is specification are incomplete. And then you ask another why, you say because there's no technical specification for packaging available, and maybe this would be the root cause of the problem. So another organized tool that you could use it in order to find what would be the root cause of a problem. The second tool that we're going to use in this phase is called the SIPOC, or supplier, input, process, output, and customer. So this is a really tool, very helpful tool that will let you go into more details into the depth of the process. And this will summarize the input and the output of a process and in a table. So it's easy, fun when you see a table that has input, output, and all the details you need to understand and study a process. The SIPOC, it's stands for supplier, input, process, output, and customer. And these are summarized in a table that will help you to understand the situation. So let's take a look into this example. For the supplier here, in this example, we have a grocery store, daily supply corporation. As the input, we have dough, butter, cinnamon, oatmeal, and egg. And in the process, as you see, you will see a flowchart diagram. Flowchart diagram is really important in any process to understand any process. So it's in the P phase, what we do, we create a simple, quick diagram, flowchart diagram, to be able to understand the process itself. So prepare the dough, add egg and butter, add oatmeal, shape dough, bake in the oven. So this is just a simple flow diagram that will help you. As an output, what is the output of this process? We will get a cinnamon cookie. As the C, the customer, so the customer could be a dine-in customer, take-out customer, or delivery customer. So by using the SIPOC diagram will help you to understand the process. It will give you even more details on the process. Let's take a look into this more detailed example. All right, here's a diagram, SIPOC diagram. So for this, we will see the supplier to be manufacturer, suppliers, gas station, sales car wash, and a printer. As the input for this process, we have cars, we have option package, fuel for cars, car washes, car needs, worksheet. As a process, let's take a look into the process. Let's take a look into the flow diagram. The process flow diagram, meet with a new client, understand client need in a new car, present options, show them some options to the client, and come to agreement on option, delivery price, etc. Sign the paperwork and hand over keys and title. As the output, what is the output for this process? New client account, paperwork to start, paperwork to dealer, paperwork to manufacturer, payment, service contract, service notification. Who's the customer? The customer for this process could be car buyer, could be dealership owner, could be Department of Motor Vehicles, or could be service departments. A requirement. What is the requirements? This is something you probably want to add to the process just to include more details. Requirements, color selection, build to order, work paperwork filled within 48 hours, in-state checks or money orders. So these are just the requirements. So this is an example for a car dealer. You will see what would be the process. Again, what's the nice thing about the SIPOC diagram? It will tell you exactly the details. You will have a better understanding of the process. Let's see, here's another example. Let's take a look into this example, which is basically making a peanut butter jelly sandwich. Suppliers would be cupboard. Experience is an input. What is the input for this process? Peanut butter, jelly, plate, knife or butter knife, bread, knowledge, operator. The process, what's the process? Setup, apply the peanut butter, apply the jelly, final assembly. As an output, you will taste, construction, on time, quality. Customer, nephew. Requirements, you could add the requirements on the right side. Okay, now you could go into more details. Now you could, for as you see here, we have setup, apply peanut butter, apply jelly, and final assembly. Right here, we go deep into the setup process and we come up with the input and output, the XY diagram. Now we're talking about variables, and we'll give you an idea on what is needed. So, for example, in the setup, only one process. Let's go deeper and find more details about the setup. In the setup, you will see sandwich maker, setup area, standard, which is work instructions. There should be some work instructions around customer requirements, lighted area. In the time, it's uncommon or common. It depends on what you add. Just another details to the process and the output. What the output will be in here. The output for the setup process, you should have the jar of peanut butter. You have to have the jar of the jelly. You have to have a plate. You have to have a butter knife, and a bread. So all these as an output for the process. So now we're going to the second phase, which is apply the peanut butter, and you look into the input and the output for this specifically for that step. So again, the idea of this, they'll give you more details. We need to collect as many details as we can so we could analyze, improve the process. Another tool, what we could use, it's the XY matrix or the cause and effect matrix, where you put the X's on the input, which is the X's on the left side, and the output on horizontally on the column for each column. So the input in the rows, X1, X2, X3, and the output as a Y1, Y2, Y3, and you start giving them a rating for that. What would be the rate for that? So for example, let's continue on the peanut butter sandwich. What we do, we look into the setup. Here's the setup. We have 5 steps in the setup. We look into the input. What is the output? Taste, construction, on time, and quality. And you rate these in a scale of 1 to 10, being 10 the very good, the highest, and 1 is the lowest. And you give the total here. What would be the total? And by doing that, you know exactly which one to focus. So if you need to know where is the 195, for example, this is coming from, would be 9 times 9 plus 9 times 6 plus 9 times 4 plus 3 times 8. I would give you 195. Okay, so this is the rating, the importance based on the customer, the 9648. This is the rating. So you ask the customer, which is more important? What is the rate for taste to be a taste out of scale 1 to 10? The customer will say 9. The construction, it's like the well-constructed sandwich. How important is that? Maybe 6 is good for that sandwich. Not no. Having the sandwich in time, rate of 4 out of 10. Quality, it's really important to have a quality sandwich, so I'm going to give it 8. So right here, once you finish this step, the input for that step, you evaluate yourself as internal. You say, okay, how did I do with the taste? Okay, that would be 9. Construction, oh, looks very good, so that would be 9. On time, excellent, I was on time, so I'm going to give it 10 or 9. Quality, that it's not that good quality, so I'm going to give myself 3. So this is exactly what you need to do. We'll go take more details, or this were applicable for the QFD function or quality function deployment, where we talk about more matrix um, to apply the customer voice or the voice of the customer. Very similar process, very similar matrix, and we will talk about that in more details. And now for the next tool that we're going to talk about it's called the FMEA, which stands for Failure Mode and Effect Analysis. And for this tool, we identify effects and consequences of a potential customer or process failure. Identify methods to eliminate or reduce the chance of getting a failure. Information from process map, Ishikawa diagram, and QFD are used to create the FMEA, the failure mode and effect analysis. Okay, so let's take a look into this this diagram. This is just to let you know that we could construct the FMEA using input from process map, QFD, or Ishikawa diagram. Use all these information to build the failure mode effect analysis and effect analysis. Okay, how we could construct that, or what the form of the FMEA look like. This screen show you the format or the template for the FMEA format, and you will see that you will see the input, the potential failure mode, the potential failure effect, and the severity. So these, I want you to focus on these three things. I'm going to try to explain it very quickly here. So if you focus on the severity, occurrences, and detection, and once you find out, you find the RPN number. You find it, and based on that, you could identify the risk of having that issue, of having that failure. How severe is that failure? So again, the first section on the left side is to identify the failure mode and their effect. The second section would be identify cause and failure of failure mode and control. And then the third section would be prioritizing how severe is that issue is, and determine and assess an action. All right. So how to construct the FMEA? We construct FMEA by following these 11 steps. The first step is to identify potential failure modes. The second is identify potential failure effects. The third one would be determine severity rating for effect. Now in this is what would the first parameter. You need to identify how serious is this effect. Is it difficult? And this should be a rate of scale of 1 to 10. 1 means the lowest, not severe. 10 is serious, severe, or very dangerous. Number 4, identify potential failure causes. Number 5, determine the occurrences, how often, the frequency. Again, scale 1 to 10. This is the second parameter. Now, performing the null hypothesis, this is an optional thing, so we're going to skip number 6 and 7. Going to the 8, describe the current controls. What do you have? Some steps and procedures to control this failure if it happened. Number 9, determine detection. How good your system in finding these or detecting these issues. Evaluate the current process control in place. Scale from 1 to 10 as well. Number 10, calculate the risk priority number, RPN number, which can be calculated by multiplying the severity rate times the occurrency times the detection rating. So you multiply these together to find what would be the RPN number. Determine action to be taken. This is very important tool that we could even use it not only for Six Sigma, but for also risk management methodology. In order to risk and reduce the risk for any process, we could use this FMEA technique. All right, now somebody will say, okay, how I'm going to identify these factors? How I'm going to give 9 or 5 or 10? So, well, there's some guidelines you could use to identify if this is a 1 or a 10 or 5. So, for example, here's some way to uh, help you identify the severity of the effect. So, the effect. Let's take a look into here. Hazards without warning. This should be a 10. Should we give it a ranking of 10? Maybe endanger customer. So this is very highly severe ranking with a potential failure mode, fitness for use and efficiency of product and non-compliance with government regulation. Failure will occur without warning. So this is, we give it a 10. Uh, Hazardous with warning. If there's a warning, this could be a 9, may endanger customer. Very high severe ranking when a potential failure mode affect fitness for use and efficiency of product and non-compliance with government regulation. Failure will occur with a warning. Let's move on here to the moderate. The moderate, we give it a 6, a rate of 6, or a rank of 6. Minor impact upon product flow or probability of acceptance. A portion of product less than 100% may have to be scrapped. Product is functional, so this is a moderate, but still the functional, but at a reduced level. So maybe you will see a cosmetic defects, customer experience discomfort. So this is kind of a guideline for you to see if what rating should I give? Should I give it 9, 8, 7, etc.? That's for the severity of it. Now for the second factor, we need to find out the possible failure rates. How often the occurrence, how often this failure happens. So if it's more than 1 in 2 times or 1 in 3, then that would be ranking should be 9 or 10. If it's high, 1 in 8 or 1 in 10 depend on the process capability, of course. Now, if it's 1 in 80 with a process capability of 83.83, that ranking should be 6. If one failure happened once every 400 times with a capability more than 1, that would be a rating of 5. Remember, scale 1 to 10. 10 is the high dangers and 1 is less important. So as you see, the process capability impact the ranking here. So the lower process capability, the higher ranking. So as long as you are able to improve the process capability, so the ranking would be low. So for example, if it's happened once every 15,000 times, when you have a process capability of 1.33, which is very capable, that would give you a ranking of 3. So again, this is another guideline on which to select 1 to 10 probability or ranking based on the frequency, how often this failure happened. The last parameter, which is detection ranking, how good our system in finding this failure before the customer knows about it. So for example, if you could put a 10 ranking, if almost impossible, no known controls available to detect the failure. There's nothing, any system that you could detect the failure mode. Very important or very remote, which is giving a 9 ranking. Very remote likelihood current control will detect failure mode. Remote, that's the detection. Remote likelihood current control will detect failure. So it's just basically based on your, does it make sense? How often, how quick your system will be able to detect the issue or not. So if you are able to define the issue quickly, that should be a ranking of 10. If you are difficult to find difficult to find the failure, then that would be a ranking of 1. All right, so let's take an example so we could wrap up this video and talk about a different topic. So here's an example. which we have a process, temperature measured using ear canal thermometer. We have this thermometer, and we need to know that we need to apply the FMEA technique. Okay, so the first thing that we need to do, use the template. The first thing in the template, potential failure mode. What is the potential failure mode? The potential failure would be the thermometer will not work probably. Okay, the second thing that we need to do, potential failure effect. So if did not work, what would happen? What is the effect of that? A wrong temperature recorded. So if the thermometer did not work well, what is the failure? Then the wrong temperature will be recorded. How severe is that? Okay, out of 1 to 10, a scale 1 to 10. Then we give it a 9 because this is a really severe. Next, potential causes. If we have this issue, what the potential causes? Why this has happened? The thermometer not calibrated very well. So, okay, occurrency, how often this will happen? That would be 4. It's not that many. Occurrency, rank of 4. Null hypothesis, we said we couldn't skip that if we decided to. No need for it. Current control. So what is the control that we do have in this process? We do a random testing, detection how good this control system in finding this. This is very good. I would say 80% or 8 out of 10. Now multiply 9 times 4 times 8, that would give you 288. Recommendation action. What action should be taken? Recommendation action should be taken because of high severity level, corrective action necessary. Because of high severity, which is 9. Look at that. So maybe this is this is the RPN number is important when you have several factors to focus on one of them. However, if it's only one thing, look into the severity. As you see, the severity is 9. So therefore, you have to find a correction. You have to take a correction action to solve this issue. All right, let's read some of these tips here. Determine corrective action to be taken. Please note that corrective action has to be taken in the following cases. When we have to take a correction action, we have to take a correction action when we have a severity rating very high, 8, 9, or 10. So failure has very high impact on the customer. In this case, severity rating is 9. So we have to find a correction action, and we should take that. Next, when we should take an action, when we have an RPN is very high. RPN identifies area of greatness concern. So it is a good indication of which effect need to be corrected, and also identifies the important causes that need to be fixed in order to take care of that. So if we said if we find the RPN as high, then we have to look into this. This is a serious thing we have to find. We have to recommend an action. We have to take an action to correct this issue. Here's another example. We look into the severity times the occurrences times 4, just to show you exactly what you need to do. You have to find the function, the process, the failure mode, the effect, the severity, cause, potential control, and detection control. Multiply all these by each other and find what would be the PRN. So as I mentioned, we have several factors here, 1, 2, 3, or 4. To me, if you look into the RPN, you will know which one to focus on. You will see that, okay, paint thickness meet the requirement specification. So this is where we have to take the first time to think about it. We have to take an action. We have to solve this issue. Why the paint thickness did not meet the specification? We have to know exactly why is that, or why the paint layer is too thin. This is the failure. This is the issue, and we have to look into. We have to take an action to solve this issue. Another thing about the QFD, or another tool that we could use it, is the QFD. And this, I'm going to put it on another video because this is a really important function and very important tool, quality function deployment, or the house of quality. I'm going to put it in a different video. So I'll meet you in another video. Hope this is helpful. If you have any question, please comment below, and I would do my best to answer your questions. Thank you so much. I'll see you in another video for the QFD and the process capability and how we could conduct the process capability. Thank you so much.